Okay, so how to present the chemical equation? Okay, that also we are going to discuss today. So especially we are discussing about the symbols. Like if we want to write like complete like sodium means SODIUM, sodium. In order to write a complete spelling of that particular element, so that in order to make the things easier, so there are some formulas or symbols for that 118 elements. For example, sodium Na. So why can't the sodium can be given as so? Because it is obtained from a Latin word, according to which scientist? Who is the scientist? Berzelius. John Jacob Berzelius has given an easy way to remember the symbols based on the 2-letter symbols and 1-letter, 2-letter, 3-letter symbols. In what sense he has taken the prominence of the first letter. If the element having the same kind of first letter, elements repeating with the same kind of first letter, so he has taken from the second letter, and he also used the Latin words, and he considered the place, area, country names, and he also taken interest on the basis of scientists. Not only he, after the end of his century, this was established. Whatever the work he has given it, based on that work, the remaining scientist has given their views. Yes, here 118 elements were discovered so far. From that 92 elements are obtained naturally and 26 are artificial or man-made. Actually, what do you mean by element? It is a pure substance which cannot be broken down into 2 or more simpler substances by any chemical reactants or reagents or any chemical reaction. Pure substance which cannot be broken down into 2 or more simpler substance. So if I take a gold element, if I want to break the gold element, when I break the gold element, I'll get gold atoms only. Any other kind of atoms will be obtained from pure gold element? No. That's why elements are considered as pure. Okay, what do you mean by atom? The smallest part of element considered as atom. Atoms which cannot be broken down into simpler pieces, given by John Dalton. This statement was given by John Dalton. Ancient like alchemist means different chemist, different scientist has given different views on the basis of giving symbols previously, early times. So there are 3 main principles, they have given the 4 elements considered. Within the 4 elements, the elements which were found at that particular time has given or sorted into that 4 different zones. What are the 4 different zones, children? Fire, air, water and earth. Fire, air, water and earth. These are the 4 different zones were given by this ancient alchemist. And John Dalton, after the alchemist, John Dalton worked on that. Especially based on that pictorial presentation of the elements. Before that, these alchemists have given different views. Okay, so he has like alchemist has divided the 4 different zones, like 4 different criteria zones. Within that 4 zones, based on the physical state of the matter, they have sorted them into between that 4 zones. Like what they have taken the common thing, like they are obtained from under the earth, so they have zoned under the earth. If they are obtained from the air and like moisture, then they have given the zone under air and moisture. Based on that criteria, they have sorted. But each and every 118 element has its own unique properties. So that is the main drawback by the alchemist, which were not given that specific identity for each and every element. They have just sorted the elements based on that 4 criteria, and they have given that particular, that they just given the vacant occupied spaces to the elements. Understood? So that is a big drawback for the alchemist, and which was established like a pictorial presentation. That idea was implemented by John Dalton, and he has given different symbols based on that pictorial presentation. He has given few elements. But even there is a big drawback for even with John Dalton also. What are his drawbacks? What are these drawbacks? So if we go with the complex compounds like C6H12O6, if we go with the complex compounds, in that sense, to draw or to remember all the pictorial presentation of the element is very difficult. And it is very tedious to draw, like C6 means 6 carbon pictorial presentations and 12 hydrogens and 6 oxygens. Okay. So in that sense, it is very difficult to present it. So that is also a big drawback for John Dalton. Especially they have worked on the presentation of the symbols for the elements, but even though there are many drawbacks. So at 18th century, that modern view in the sense, now at present we are using and implementing the idea of John Jacob Berzelius, Baron John Jacob Berzelius, who suggested a simple presentation of the elements with symbols, which are not obtained or different symbols which are completely out of track, but they are within that element. So if we are by using spellings, we can easily note down the symbols. But within that spelling itself, he has given the prominency of the first letter, second letter, even with the 3-letter symbol. So, but he has given some views and rules. Based on that rules only, even now, IUPAC is presenting the naming of the symbols for that element. What do you mean by IUPAC, children?
International Union of Pure and Applied Chemistry.
Very good. Excellent. So, like IUPAC gives the recognition of the elements by giving or naming the elements. There they have IUPAC is going to do all these things. Then only we'll get the particular element name and recognized name. So all over the world, if you go anywhere in the world, if you go, that sodium means sodium all over. It's like international union in the sense, wherever we go about the chemistry, the element names are common. Like how we are dealing with alphabets, they are recognized all over the world. So at the same way, he has given some rules based on the first letter, 2 letters, and Latin names. So you can go with it. As we have already discussed about the Latin names and everything. Based on the first hydrogen, oxygen, chlorine, bromine, iodine, all these are considered as first letter. Based on prominence to the second letter, why he has given the prominent to the second letter? The main reason is that if the elements are common with the same letter starting with first letter, for example, hydrogen starts with H, helium also starts with H. So in that consideration, he has given the prominent to the second letter. So how to present it? This is very, very important. The common mistake whenever I see the children commonly what they'll do, they'll give the symbols, the first letter with the capital letter and second letter also with the capital letter. That's a big mistake when they present the symbols. The first letter always should be the capital letter and second letter always should be the small letter. Understood? Yes or no? Okay. In that consideration, he has given the prominency to the second letter. And the next one, these are the second letter prominent letters, or these are the third letter prominency. If second letter also common with the few elements, so he has given the prominency to the second letter or the fourth letter also. And somewhat when we spell the name of the element, for example, chlorine, when we spell, C doesn't sound much. Am I right? Chlorine. So then which is sounding more when we remember the element L. So in that sense also, he has given the symbol, like second letter giving the prominency to the third letter. Like it sounds or stress, so that it is easy to write the element name. Understood? So keeping all these rules in mind, he has given the symbols and we can easily remember the symbols. There is no much confusion about it. To make the things easy, to remember all the 118 element symbols, in that consideration to make things easier to the mankind. So in that consideration, he has given the symbols. Even now, though Berzelius is not at present time, but his ideas only we are going through by giving this element names. Understood? But different names has given by the scientists. Even now at present, they are working on that to identify many elements by using IUPAC, recognizing the element. They want to invite or introduce few more elements. But still, IUPAC need to recognize the naming, then only we'll get. I think 2 more new elements were already found previously, like 2 years back. Even now, we did not, they did not implement or imbibe that periodic table because of that permission given by the EU. Understood? So symbols of the Latin names, these are the Latin names: natrium, thallium, ferrum, cuprum, argentinum, ornium, plumbum, hydrogenium, stannum, stibium, wolfram. So these are the names of the elements which we find in the periodic table, but these are obtained by the Latin names. Symbols were obtained from the Latin names. These are the symbols. So what are the main concept by giving the symbols? To make easily the significance of qualitative and quantitative of the element. So first one, by seeing what is the qualitative thing to know by seeing the symbol or the element. For example, if I want to write any symbol, carbon dioxide, I won't write completely the carbon dioxide on the board or on the book. Definitely I will go with the symbols. If I'm perfect with the symbols, definitely I'll go with the formula by using symbols. So when I'm writing the oxygen or carbon dioxide, definitely by seeing the symbol, we know that carbon is present in it and oxygen is present in it. Am I right? Quantitative significance means if I want to write O stands for oxygen. By seeing the symbol itself, no need to go for spelling. So we'll get an idea about it. If I write N, so definitely in your mind, nitrogen. The quality of the thing like carbon dioxide, no need to write the entire spelling of the carbon dioxide, CO2. By saying CO2, we know that carbon is present in it and oxygen too. Carbon and oxygen too. So this is the qualitative significance of the elements. By using symbols, easily we can identify what kind of element is it. Okay? Understood or not? Here. Yes, very good. Arna? Yes, Arna? You want me to ask anything?
No, ma'am.
Very good. So here quantitative representation in the sense, quantity means how much quantity, how many atoms are present in it. By using a formula, like here CO2 I have written. By qualitative means carbon is present, oxygen is present. What do you mean by quantitative representation? Quantitative representation means how many atoms of carbon, how many atoms of oxygen. And even if you go to the higher classes, then definitely you can know how to calculate atomic weight and molecular weight of the element, so that how much is the mass of carbon dioxide is present in it. Okay, so the quantity, the mass. Quantity, the mass. For example, when you have taken any special dish, okay, I want to eat. When we are eating the dish, we can easily know that quality means what are the kinds of vegetables present in it. That is qualitative significance. What do you mean by quantitative? What do you mean by quantitative? If major amount of one kind of vegetable is present inside it, so that you'll be having an idea that, so this is the main dish. This is the main significance by using symbols or formulae. So this is the main significance. We know that what kind of atom is present in it, and what is the mass of the atom and quantity. How many atoms are present in it, and we can easily calculate the atomic mass and molecular mass of it. When you go to the higher classes, definitely you know how to calculate the atomic masses and molecular masses of the